Hey everybody, I'm back to dig in a little bit with data on the OBD1 GM controllers, and particularly my 85 IROC Camaro. You've seen before, I've had some videos that I've made where I've been trying to dig in and understand, one, how to get data streams similar to ScanTool, which I've done. I've used WinALDL. I have a previous video where I showed how to use the USB cable and get it configured so that I could use it with WinALDL and then or TunerPro. It should work either way, but it got the ALDL cable into the USB port on my laptop. Second thing is, once you get the data stream going, one of the curiosities, wouldn't you like to know, is how your car is programmed, what's in the chip, right? It's a curiosity, especially for me, because I'd like to know what the spark advance curve looks like. I'd like to know, how do they calibrate this car? And if you use TunerproRT, you can not only do the data stream, but you can find the data and look at the data for your car. So up front here, a couple of things. One is, I'm going to walk through and show you how to set up TunerPro, because frankly, I found some things online, even from videos from TunerPro, but I'm gonna boil a couple things down because it took me a while to get through it. Second thing is, I'm going to take a look at what's in my car and what's in my 85 and what's in the chip, and how you find the information to do that. And the third one, and this one I think I'll break off into a separate video, but I have a subscriber who's been having trouble with California emissions, and that actually motivated some of my previous videos, like on the catalytic converters and air pump diagnostics and so forth, because he's been having trouble passing. And the latest one that we're looking at is EGR calibration, and trying to understand what it should look like. Because what he was describing to me is much different than how my car performs. And so, like I say, rather than making this too long, I think I'll probably split that as a separate video and walk through and just compare what the EGR calibrations are in each model year and see if I can give him some help. But so let's dive in right now. And what I have up here is the website for TunerPro. And let me start by saying, in my videos with TunerPro, there are two basic versions. They have a version 4 and they have a version 5. And because my car is at the very front end, it's older, and version 4 had been around for a long time, and I looked at some screenshots and it looked a little simpler. What you saw in my earlier videos was I set up and I ran version 4. And it seemed to work just fine. And that's what you will have seen. Now, what I decided to do, as I was digging in here and trying to look at some of the detail, I thought I'd move to version 5 and see if there are any other, because it has more knobs and more bells and whistles, as they would say, that it might help me dig in a little further. So let's walk in here, and this is TunerPro version 5. Now, if you want to use version 4 like I used, it's where it says right here, it says Legacy available here, and you can click that link and you can find the files and you can download them and install them on your own computer. And that works fine, and that's what I was using when I collected vehicle data and plotted it out for you in the previous go-around. Here's the current one for Windows 7 and above, and you can download it right here at this link and install it. There's a registration. You can actually use it without registering it. There's a 10-second timer that you have to wait for to let it time out, but they'd really like you to register and pay if you're going to use it. And that's the best way to approach it. So anyway, I've downloaded it. I'm going to walk through, look at a couple of other web pages here as long as we're at it. So, here's the page for the legacy downloads. You can get the regular and the RT. And the RT is the one that gives you real-time data. It gives you the ability to do a data stream and to dig in a little deeper. So this is really the better version. But there's version 4 if you want it. There are a number of links over here on the side. Like this one says downloads for definitions and plugins and bins and so forth. There's more data over there. And so there's one here that says download bin files. And for demonstration purposes, I have a better place that I'm going to point you in a minute for bin files. Then if you need to get in the downloads section here, you need to get definitions. So this is the page for definition files. And if you come down in here for GM, you'll find all of these that say mask IDs and bin definitions and data stream definitions. So if you find your car, and if I go down to, here's the one that says 1F here is my 85. So it says 85Y, 85F body 5 liter LB9. The A20 is the data stream definition. The 1F is the mask. That's the ECM part number. I'm sorry, that's the definition, and that's the mask, they call it, which is the ID for the definition. Now, one of the tricky things is when you go from version 4 to version 5, and this is one of the reasons why I stayed on version 4, is they have ADS, as in SAM, files, and those are the data stream definitions in version 4. And it appears in version 5 you need ADX, like Xerox X files, and that confused me a little bit. So I stayed with ADS because there were not any ADX files. But once you get into the tool with version 5, there's a way to convert that file and import it and basically get an ADX definition file. I haven't tried collecting data with that yet. I'm going to be on my to-do list for the future in version 5. For today, what I needed is the XDF file and some bin files. So you can click on those and download them to your hard drive. Then here's a page called the data stream definitions, and this is where you'll also find explanation of what's in those files and any other detail on what's in the file. All right, then you want bin files. Bin is a shortened for binary, and your PROM, your calibration chip on your ECM, has binary file in it that is what tells the ECM how to operate. It's your calibration file. It tells you, what should the spark advance curve look like, what should the idle speed look like. All of those things are in there. There are two ways to get bin files. The first one is to go buy what they call a programmer and take the chip out of your ECM. You got to look at your service manual how to do that, because each model some of them have different ways to pull the chip. You can't always just yank them out. Sometimes there's a carrier or something. Any case, and you can download the data from your chip into a bin file here and run it in TunerproRT. Or sometimes you'll find people have already done the work for you, and you've got to be a little bit trusting, because it may not be accurate, so just use at your own risk kind of thing. But there are some websites out there you can do some searching. I found this particular one here, which is www.gearhead-efi.com, and it's all kinds of things about electronic fuel injection. And here's a here's a page. I'll start with a frequently asked questions page on EFI with a lot of things in here for General Motors controllers. And that's kind of the basis. There's even a tutorial in here for how to get going with TunerPro and what you need. Then you can, here's a page. It's a forum, but it's GM ECM bins, or the binary files, TunerPro definition files, and more. And you can come in here and look up by your ECM part number a different page. So, for example, here is my 85 has a 1226870. That's the $1F mask. And here's a whole page where someone has taken and pulled all the binary files that they could for an 85 Corvette Y car or an 85F car, Camaro Firebird. And so here are the definition. Here's the ADS, which is the data stream. Here's the XDF, which is what they call the mask. Here's there's one here that they call updated that's a little bit larger and has a little bit more data. Then down below here, there's a whole stack. These are bin files, binary files. So if I go down here, there's the one that says FTM 85F car 5-liter TP tune port automatic 700R4. That's mine. How do I know that's mine? If you go to your ECM and you remove it from the car, or pull it down out of its storage location and open up the little door on it, you can see over here this is the PROM, this is the calibration chip. And General Motors has a thing they call a broadcast code. And a lot of times, got to be a little bit careful. Oftentimes the broadcast code and an RPO will match. Sometimes they'll be different. But if you go into, if you've been working on, General Motors cars, there are famous RPOs for engines like LT1s, right? That's a regular production option. In some cases, there'll also be a broadcast code with that same in the plant. A broadcast code tells the plant what to build. And so there will be multiple ECMs that, at the time it would have been Delco would have built multiple ECMs. And they'll have a different calibration chip in them. And the only thing that identifies the different calibration chip, to make it easy, is usually a 3 or 4 letter. I don't think I've seen, there might be a 5, but normally it's 3 or 4 letter broadcast code that tells the guy on the line what part to pick out of the bin and put in. And then this ECM, when you're in a vehicle assembly plant, there will be a broadcast code on the ECM, FTM, and that FTM will say, oh, hey, when the build sheet for the car, car's coming down the line, and an assembler's got to pick an ECM out of the rack and plug it into the car, they'll be looking for that broadcast code. And if you go to a GM parts manual, you'll typically find the broadcast codes called out in there, where there's a special one. So for my 85, I wanted the bin file for an FTM. It's right here, and I can download that. And you'll see there's 85 Corvette. There's even one that says it's a Hypertech chip that somebody's read off and downloaded. Here's an HLL. Now I don't know what the difference is for an HLL. It's a different broadcast code, and it could be for a different axle ratio, or tire size, or whichever. But there's for an 85. Then there's one here that's called for a 7165, which would be the ECM for 1986 and beyond. Well, 86, 87, 88, 89. I'm not sure where it stops, but it goes through 89 anyway. And here are the data stream files, and so here's the ADS file, which would be for version 4. Here's the XDF, which would be the what they call the definition file, and so forth. And so you can go through here, and there's the page for, you know, all I did was go through here and search by ECM part number and do a search. Now, you can't just go in here and get these files. You have to sign up for a membership. The membership doesn't cost anything, and I did that. There's a register link up here in the corner, and you can register for free. And I think it took them 2 or 3 days. I think this is a volunteer kind of thing. It took them 2 or 3 days to enable my account so that I could go in. But you can't download the files unless you register. But again, stack of 86s. There's another one here which is all the parts for an 87. And each model year is typically just a little bit different in their definitions. Here's one for 1989. And so I'm going to go into more of those later on. Let's see what this last one is. Oh, this is some instructions on data tracing. I'm not ready to go down that path yet. So, but this one seemed like a really good one to start at. And so if you know what your broadcast code is for your ECM, for your PROM, then you can dig in here and find it. So now to the setup part. Here's an almost blank one. I've got it set up. Here's a TunerproRT. I've installed the program. Like I said, there are really 3 things you got to know. If you want to collect data, you need an ADS or an ADX file. And you would get that over here under this one that's called acquisition, and you can load a definition file. And when you install the Tuner Pro, it sets up a directory for you with bin definitions, which are the XDFs, the bins, which are BIN, and the data streams, which is ADS or ADX. And those are kind of the 3 big buckets you need. So when I say I want to do acquisition and load one, it says, hey, you know, I want to go load an ADS or an ADX. Let's see if it'll let me load a See, here's a bunch of ADS files, and that A20 is mine. See, it won't load it because it's not supported that way. So you come over here to acquisition, and it says import definition from ADS, and then I can do it. And now I ought to be able to go collect data on here. That's number 1. That's if you want a data stream. Here's the XDF, and this is the definition file. And so I'm going to select an XDF. I'm going to get the one for my car. And I've actually added a few things in here because I've downloaded all those files. So here's for my 85. There's a 1F. And when you load the definition file, that loads everything up over here, over on the left side of the screen. So what that means is, so these are all the parameters that can be calibrated in your chip. This is the XDF is the definition of what, it's how the data is laid out on the chip and what you can change. But if I go in here and I say spark advance versus RPM versus load, I can double click that and I get a table. That's cool. But you notice something? Yeah, it's all zeros, right? So this is where the bin file comes in. The XDF gives you what you need to know what the parameters are, but now you need a bin file. And instead of bin definitions, we're going to back up a level. We're going to go to bins, and we're going to go to 85. And here's my FTM. Okay. Now, up here in the header, it says FTM 85X car. Now it knows 85F car. Now it knows what car I'm looking at. And there's the XDF file. And there's the XDF file. Now when I click Spark Advance versus RPM, Shazam, I've got data. So here's 400 to 4800 RPM. This is a load variable. I think this is actually the LV8, which I mentioned in a previous one, where these numbers go up to 200. Yet I never had an LV8 number over 8 or something in my previous data collection, so I still don't quite understand what was going on there. But anyway, so here you can get Spark Advance all the way up to 42 degrees if you're at light load, and 27 degrees if you're at wide open throttle, basically at heavy load, at high speed. This is kind of the three-dimensional map. And if you go up here, you can compare them. You can compare with other bins. There's fancy things you can do. Or you can do this, which is hit that button, and you'll get the Spark Advance. You'll get a chart. So now you've got how does the Spark Advance see? There's RPM. There's load. I'm sorry. There's got to get the right one here. Yeah, this is load. I've got 1 point selected. That's all the way at the bottom. Okay. So it says 14 degrees. If I go over here and click 208, that's down here at the bottom. Heavy load at low speed. That's heavy load at wide open throttle is over here. So this is the load. This is load. Now see, this one says in grams per second. So that's an interesting. That looks like it's in an airflow mode. More for me to learn there, but so you can get a Spark Advance graph. When you go down this data, this one at the bottom is called tables, and this is all, just like you saw, it's a table. Up at the top are what they call scalars, which are single values. So here's the the fuel cutoff speed. If I double click that one, it says you can go 255 miles an hour before they're going to turn the fuel off. Basically, it's not a limit. It's out of the way. There's the fan minimum to enable. So here it says 106 degrees C. At 106 degrees C, it's the minimum temperature where it'll enable the fan. And you could move these. You want to kind of be careful. If you're using one of these bin files that you've downloaded, you can change it, and then it won't be original anymore. If you were doing your own tuning, you'd come in here and say, hey, I want to modify this. I'd move this around, and I'd save it, and I'd make a new bin file that I could burn to the PROM chip and put back in my car. This is where you would actually do programming, but you need a little more hardware because you need a physical device to plug into your computer that will actually burn the chip. You need to have the right chip to burn. That's more complicated. For today, it's just, wouldn't you like to know what the engineers in the factory, what Chevy put in your Camaro to as calibration? So people go, well, what about initial Spark Advance? Why is it where it is? Well, it's because they assumed it to be 6 or 5.98 degrees. And so when you go look at your Spark Advance table, you start there. And then you go add in Then you go add in the degrees, well, not add in. They're assuming that your initial advance is 6, and so then this is your total advance, assuming that that's at 6. If for some reason you set this at 0, then the computer wouldn't know any different. It would think it's putting out 42 degrees, but you'd be 6 degrees short. So you kind of want to work those things in and make that work. But if you want to know what your any of these things, where your torque converter clutch locks or unlocks, IAC steps. There was one in here. Well, I'm going to hit one other one here. See, PROM ID. This is kind of a simple one. But when I go to my scan tool gives me a PROM ID of 21. And by golly, I got the right bin file, because it's, unless it's been corrupted or something, it matches, right? So I always hit cancel on these, not save, because I don't want to save the data. But you can go through here, you can see acceleration enrichment. Also, one thing I found that kind of threw me off for a minute in version 5 here, it looks like this table I got IAC warm park position. It looks blank, but it really isn't blank. It's the box just pops up kind of narrow, and so if it's minus 40, they're going to have the IAC open farther than if it's hot. If you're at 50 degrees C, you're going to get, the IAC setting will be a lot lower in steps. So this is where all the data is. Here's target idle RPM. Some of these are kind of interesting, just if you're curious, why does my car idle where it idles? Well, here's the RPM versus coolant temperature. Again, if it's minus 40, they're aiming for 850. If you're at 32 degrees, you're down to 800. If you're up and the engine's fully warmed up, they're targeting 500. So this is the whole span of, a lot of times, you jump in your car and you go, gee, I'm half warmed up and the idle isn't down where it normally is, it's still up high. Well, these are the factors. Now, sometimes there are still other things that can cause adjust it from there. We were talking about EGR a few minutes ago, and if I go down here, I have an EGR table for mine. There's an EGR, it says duty cycle versus RPM versus load. So from idle speed to 2200, and then going up with load in this direction. And it looks like that, and this one says LV8 counts, not airflow. So this is how my car's programmed. Now I'll have to still dig into the other ones a little bit, but and then I even have some extra tables like this one, which is a multiplier, so that if it's hot, the multiplier is 1, but if it's like cold outside, the multiplier is 0, and I think if the multiplier is 0, you would have nothing. You would have no EGR, which shut it off until you got up here to 30 C, and then it'd be 0.25. And there's also a multiplier against load, and that one is a 1. Now, a little more insight into things, into how these kinds of things work. Now, I wasn't working on controllers in these days, but in recent years when I was working on hybrids and so forth, while I was not working on controllers directly, I was approving changes to controllers, and I was working with the calibration and the software folks to implement hybrid software in controllers. And so I understand a little bit of the architecture. It's a whole lot fancier and a whole lot more powerful than it is in these old ones. But normally what you'll have is you'll have some form of read-only memory that you can't change. Well, in the new ones it's electrically changeable, right? It's got flash memory in it. So you can flash software in, and you can flash calibrations in. On these older cars, somewhere in the ECM there's a chip that has the software, the read-only memory software that you can't change. And then there's this PROM chip, which is the calibrations that tell that software what the special parameters are, these tables that are coded in the software so that it knows what to do. And as you're going through these, you can see these parameters, but you don't know what the software says, and you don't know what the software engineers might have done in the background. So you know, tinkering with these is always a little bit risky if you don't know what the original code is, because the original software, the guys, when they're calibrating these tables, they know what the software commands are and what the software will do when they change one of these. I have an EGR duty cycle. I don't know exactly sometimes what these different functions are and what's hard-coded to be done. So it's just a caution that this is a great window into how your car operates, but it's not everything. It's not the operating software, it's only the pieces that you can change. And the software engineers could hard code things into the ECM that we can't change, and we don't know what they are because we can't go look at them. Those are in the code that's in the controller itself, in the part number. This is some insight, and I really enjoyed being able to come in here and just look at the parameters, because they've got factors in here for locking the spark retard. Now this table on mine is 0. Knock retard attack rate versus RPM. They've got timeouts. It's just really curious to dig into these things and think about. Here's one, injector offset versus battery voltage. So in microseconds. So as the battery voltage changes, they're going to adjust the timing on your fuel injector pulses. In other words, how long does the injector stay open? The lower that your battery voltage is, the higher that number is going to go, until you get to a certain point here where it falls off. And but the fuel injector timing will take into account your battery voltage, because the battery voltage affects your fuel pump pressure and so forth. It's a kind of a cascade. So that's my story for the moment. The 3 things you want to go at is you want to find a good bin file. You want to make sure you use the right XDF file, the right definition, or things won't match up. And the third one is, if you want to get a data stream, you need an ADS or ADX file, and then go at it, so to speak. And this is the basics. I'm still going to come back and do something, do some compares on the EGR, but as I said earlier, I'm going to make that a separate one. So that's TunerProRT version 5, and that's all for now.